with operating system operations. What are the different operations that operating system will carry out? So basically we know that operating system is an intermediary between the user and the computer hardware. So not only it acts as an intermediary between the user and the computer hardware, OS will act as a resource allocator, it will coordinate, it acts as a coordinator, it also acts as an interrupt driver. It will drive the several interrupts, interrupt driven by hardware. I have multiple jobs, so I will store all these jobs in queue. How is it I will store? I have a memory space called interrupt service routine. So there I am going to put it in a queue. Those are all called interrupts. They are requesting for some service. They are sending some message. This is a job I want to complete. These are the resources to be required. So when these messages are received by OS, what actually the OS has to do? It has to drive this. It will provide the service for each of these jobs. So OS will also act as an interrupt driver. So it is interrupt driven by hardware. We were discussing about the software interrupt. So it is also known as trap. Sorry. So when it is going to arrive, when this error is going to generate, where sometimes, for example, when you perform some, when you execute some instruction with respect to division by 0, this is one of the example, right? So when for such kind of execution, there exists an error called software error. So this is an error which is also known as exception or a trap, right? So this will request for operating system service to recover this error, to overcome this error, to resolve this error, fine? So other process problems include infinite loop, processes modifying each other or the operating system. So how is that operating system operation starts with? It acts as interrupt driven, it resolves the error, software error, then it continues with, it solves the problem include infinite loop. Say for example, CPU will perform the operation in two modes I was explaining. What are those? User mode and the kernel mode. User mode, it executes the internal instructions stored in the system. Kernel mode, whatever the instructions sent by the external device, interrupt handler will come into picture, right? So in that case, so when, for example, if the CPU is stuck in kernel mode, it cannot come back to the user mode. That means what? It is stuck in the infinite loop. It cannot complete the job 2 or job 1. It is stuck in one of the job. So how is it going to be handled by OS? So processes will be modifying each other or the operating system. So operating system should handle the CPU such that it should not stuck in the infinite loop. It has to complete the job one by one. So last class we studied about dual mode operation. What are those? User mode and kernel mode, correct now? So dual mode operation allows OS to protect itself and other system components. So that means what? OS will not allow the CPU to sit idle. Either the CPU will execute the user instruction in the user mode or it will execute the instruction in the kernel mode. Once it finishes the kernel mode instruction, come back to user mode. Fine. So OS will protect the resource between these two modes of operation. How actually it protects? That we will understand. We have how this OS will make the differentiation that whether the CPU is operating in user mode and kernel mode. So there is one concept here. There is one mode bit in the memory space provided by the hardware. So this mode bit, when it is 1, it is operating in one of the mode, you can assume. When the mode when the mode bit is set, when the mode bit is reset, that means when it is assigned with a value 0, it is operating in the another mode. That you clearly understand with this diagram. I'll come back to this. So what actually the OS does with respect to this mode bit? It provides the ability to distinguish between when the system is running in the user mode or kernel. If it is set, if it is value is 1, it is operating in one of the mode. If it is reset, when the value is 0, it is operating in the second mode. Some instructions designated as privileged only executable in kernel mode. So for example, I cannot execute all the instructions in user mode. The instructions with respect to the external device, the external instruction given by the outside world, those instructions are to be executed in the kernel mode. They are meant for only with respect to kernel mode. They cannot be executed in the user mode. Fine. That is called as privileged. Fine. Next we have, how is that operating system will change from user to kernel mode and then from kernel mode to user mode. So there is a generation of an interrupt called system call. So when there is a system call, that means what? OS wants to change the mode from mode to kernel. From user to kernel it wants to change, or from kernel to user mode. So return from call resets it to user. So when it is set, one of the mode it is operating. When it is reset, it will change to other mode. Following students, we were discussing about two modes of operation, right? User mode and kernel mode. That is clearly explained in the form of diagram here. Observe this diagram. I have user mode at the top and I have kernel mode at the bottom. Correct? So how exactly we are going to differentiate? OS will differentiate. See here, when CPU is executing in user mode, OS will set the mode bit to 1. When CPU is executing in the kernel mode, so if the instructions in the kernel mode are executed by CPU, then OS will set mode bit to 0. Fine. If mode bit is 0, that means what? CPU is executing kernel mode instructions. If mode bit is set, that means 1. That time CPU is executing the instructions in the user mode. Following? Okay. So initially let us assume that CPU is executing some user process instructions. Some internal instructions it is executing. I explained the timeline now, the same concept we have started with. So when there is a system call, that means what? When the IO request has come, that time what the OS will do, it will change the mode bit whose value was 1 to 0. So mode bit is changed to 0 now. That means what? The control will be given to kernel mode. So CPU now executes the instructions in the kernel mode. So once it will complete, or sometimes if you can interrupt without completing the IO job, it can go back to user mode in case of asynchronous. If it is in case of synchronous, it has to complete the IO job, then only the control will be given back to user mode. So again, when you want to come back to user mode, what is that OS has to do? OS has to change the mode bit value from 0 to 1. Then come back to user mode, continue with the execution of user process. So that is how the OS will handle the CPU between the user mode and the kernel mode. So the same steps are given here. So how is that system called? What time it has to be generated? There is a concept of timer. So I have a timer to prevent infinite loop process law hogging resources. That means what? Instead of wasting the CPU, for example, CPU is stuck in the kernel mode. If at all it was difficult to come back to user mode, that means it is unable to complete the job given in the kernel mode. Then simply it cannot waste time. If there is some other problem because of that, if it is not possible to complete the job in the kernel mode, then stop executing that program, then it has to go back to user mode. Fine. So what is it will do? We have a timer for that. We set a time. For this period of time, I will allow the CPU to attend kernel mode. If I could not complete the job in the given time, so let me stop at that stage and I will go back to my user mode. So you can set the timer, you can set the time so that you can avoid the CPU to stuck in the infinite loop. Fine. So what do you mean by process hogging resource here? Hogging resource. See, if the resources are locked, you can assume. Say for example, you are executing the instructions in the kernel mode. So CPU is locked in the kernel mode. So if the OS will not overcome that, CPU cannot come back to the user mode at all. So we have to avoid this. If more than one device is requesting for the same resource, then there is no enough resource to be allocated to all the jobs. So that time OS should decide which job it can continue with. So that is called as hogging resource. Fine. So how is this concept followed? These are the steps we have. Set interrupt after a specific period. I will set an interrupt. So interrupt means here you can consider system call. So first I have started with user process. Now at this time I want to give the control to kernel mode. So at this particular time interrupt is generated. That means system call is generated now. Fine. So operating system decrements the counter, and when counter 0 generate an interrupt. This I will explain. I think in my microcontrollers you are studying in detail these counter concepts and all. I'll just brief it here. Say for example, let us assume that you have a task. You have to write a program to add 10 numbers, you can assume. So when you want to add 10 numbers, what's the concept you have to start with? 10 numbers means how many times you perform the addition? 9 times. Number 1 plus 2, first time. 2 plus 3, second time, so on. So 9 times you are supposed to perform addition. So what is that I will do? I will set the counter value as 9 now. So initially when the counter value is 9, at that time I'll perform the first addition. Number 1 plus number 2. Now as soon as I finish executing the first instruction, which used to add the first two numbers, what I will do? I'll decrement the counter. So 9 becomes 8 now. So when the value of the counter is 8, I'll perform the second addition. As soon as I finish the second addition, I will decrement the counter, 8 becomes 7. That continues. At the end of the program, so when the counter value is 0, at that time you have finished adding all the 10 numbers. So that is the concept of using the counter, using the timer. Fine. So set up before scheduling process to regain control or terminate programs that exceeds allotted time. This means what? So you started with user process. You have set the interrupt. At this time you are ready to attend the kernel mode. Now you are in the kernel mode. You started executing the instructions in the kernel mode. Now if at all, if a job is okay, it is fuzzy, if the resources are enough, if everything is fine, if there is no error in the program written, then okay, fine, you can complete the job in the given time. If there is some problem where you cannot resolve the problem, if there is an error where the OS could not solve it in the given time, then what is that? No point in continuing the same job. So what is that it will do? It will terminate that. It will stop at that stage. It will terminate that program and the control is given to the user mode. At least the CPU will continue with the user